Yeah. Alright. Preparatory session. December SAT. And honestly, if there's like no turnout, we could just like cap or something. Cause like, low-key, we could just like study up or just do some. But I think people are gonna show up right now or soon. Wait, did someone made a deal? Someone made a D-Land high at Gartha. Wait, Ricky just sent it in the group chat. Mr. Mackey allowed, Mr. Finkel allowed. Yeah. Oh my god. Okay, okay. Alright, so Bob Reynolds. No. Just left. There he is. I'm gonna go on mute so you can talk. Yeah, I guess so.
Let's think about that one. It's saying that the consumption of eastern oysters increased substantially before the dusky sharks declined. This wouldn't really support the hypothesis because the decline in the sharks is a decline to oysters. This is suggesting that a finding other than the shark abundance has an increase in ray consumption. So this would actually weaken the hypothesis. For D, Kauno's rays have increased in regional abundance as dusky sharks have decreased. Well, that is correct because these sharks are predators. These rays are get eaten by the dusky sharks. So, um, if they're increasing in abundance, it probably means that these sharks aren't in the area. So that is correct. It supports this hypothesis. So we're gonna have to go with the D. And let's check real quick. Yep, D is correct. Yeah, these are not really that fun. I'm not gonna lie, I don't really like doing these, but if you want that, 700 plus, you gotta understand how to do these. Okay, in the mountains of Brazil, Barbensia, okay, these are just two plants in whatever family. They're on soilless, nutrient-poor patches. These people found using microscope analysis to determine that the roots of these plants, which grow directly into the quartzite, have clusters of fine hairs near the root tip. Okay, they have hairs. These hairs secrete malic and citric acids. The researchers say, okay, this is what we gotta know. They hypothesize that the plants depend on dissolving underlying rock with these acids. So they dissolve quartzite rock using the acids from these hairs. Okay. It not only creates channels for continued growth, but also releases phosphates that provide the phytonutrient phosphorus. Um, yeah, that question really sucks. Uh, but I gotta go over it. So let's go over A. Other species in this plant family are found in terrains with more soil, but have root structures. Well, this is saying that these structures are specific to dissolving underlying rock. If they had the same structure, but they were actually in soil, then it's saying that the hairs have different functions. So we'd have to cross out A. It's contradicting. For B, though these two plants both secrete these acids, each species produces the acid in different proportions. Are we talking about the proportions? Not really, because we're saying that they dissolve the rock. That's what the purpose is. We're not testing what the different proportions are and how that plays a correlation. It's not helping. It's not really hurting, but it's just not helping the hypothesis at all. Okay, see, the roots of these plants carve new entry points into rocks, even when cracks in the surface are readily available. Okay, well, it's just saying that they're their function. It's not saying that like they make it in the rock. Uh, well, let's see. I mean, it explains the function. We'll have to think about that one because it does explain the function of these hairs. They drill into the rock, so we'll think about that one. For D, these rocks thrive even when transferred to the surfaces of rocks that do not contain phosphates. Uh, what do we think about that one? Well, if the species thrive on the rocks without phosphates, it says that the plants depend on the dissolving rock partly because it gives them access. That one, it's not really correlating just because if the plants can survive on rocks without getting the phosphate, then the nutrient isn't actually that important. It's not vital. So it wouldn't be D. It's right now the only one that's looking like a probable answer is C. The roots of these plants carve new entry points even when cracks in the surface are readily available. It's saying that it dissolves. Uh, yeah, we'll have to go with C. All right. For 17, which choice? We're going back to which one is fitting best in the uh, blank. Okay. Let's scan this real quick. Mosquito repellents contain natural components activating multiple odor receptors on the antenna. As the insects develop resistance, we need new repellents that as okay, EBF, a molecular component of this flower, can repel mosquitoes just by activating this receptor. It's present in all mosquito species, and they suggest that it would be okay, important and developing. Okay. Choice A. Identify which choice is the most logically completing. Identify molecular components similar to EBF that target the activation of these receptors. Um, well, if we're researching this one, what's the most effective in repelling mosquitoes, then yeah, we do want to identify stuff similar to this thing, which is working as a repellent. So we'll keep that one in mind. B, investigate alternative methods for extracting EPF molecules. Mm, well, we want to develop new repellents, and we can already extract that. I don't really know why we would need to find new methods. We'll cross that one out. Precise. Okay. C. Verify the precise locations of this receptor. Why would we need to know where it's on it if it's working? If it's work, we don't need to know where exactly the receptor is. Yeah, we can get rid of that. Determine the maximum number of different odor receptors that can be activated by a single molecule. Well, it's working. Like we don't need to do anything with the receptors. It's working. This EBF thing works. So let's circle back to A. If we want to find stuff that's similar, then we could make something like super strong that would repel like a million ants. So I think A is going to fit best. It would be most useful to find stuff similar to this repelling agent. Okay. Stupid reading. Okay, 18. Birds of many species ingest foods containing carotenoids. So these are pigmented molecules that confer into feather coloration. Coloration tends to be especially saturated in male birds' feathers, and because carotenoids also confer health benefits, the deeply saturated colors generally serve to communicate what is known as an honest signal of a bird's overall fitness to potential mates. However, this guy, this lady, and others have found that males in several species of the Tanager genus, whatever, use microstructures in their feathers to manipulate light, creating the appearance of deeper saturation without the birds necessarily having to maintain a carotenoid-rich diet. What did all of these findings suggest? Okay. Individual male teenagers can engage in honest signaling without relying on carotenoid consumption. Um, well, Schultz's findings show that the teenagers can signal fitness without consuming the carotenoids, and it shows that like these signals are dishonest. That Um, not that tanagers can give honest signals without consuming carotenoids. So, that one is not supporting, it's contradicting. We'll have to get rid of that one. B, feather microstructures may be less effective than deeply saturated feathers for signaling overall fitness. Uh, this one you can just see it's incorrect because Schultz's findings, they show that the what are the microstructures in the feathers can give a incorrect signal of fitness, not that they're less effective than actual pigmentation. Whether the signal is honest or dishonest has no effect on how effective the signal actually is. So that is going to be incorrect. C, scientists have yet to determine why they have a preference for mates with colorful appearances. Um, are we discussing why? It doesn't really look like it. I'm not gonna lie. Uh, it it shows that her findings show that certain male teenagers may appear to be more fit than they actually are, and it doesn't have anything to do with their colorful appearances. And for D, a male teenager's appearance may function as a dishonest signal of the individual's overall fitness. Well, that is kind of the last option, but why does it seem the most correct? Well, because it is the text is explaining that the carotenoids contribute to the, deeply saturated feathers and having health benefits. And the deeply saturated feathers is usually an honest signal that the bird is generally fit. However, Schultz and just like it says that the researchers have found that certain tanagers can appear to have decreased saturated feathers even if they haven't consumed carotenoids because of the microstructures in their feathers. Uh, so it's not exactly an honest signal. It might have a correlation, but it's not honest. So this is going to support those findings. Okay. Now we're at the easy ones. This is where you could just kick back and relax. Standard English. Okay. When writing this novelist drew on her own experiences working at a publishing office. The award-winning book is Harris's first novel, but her writing blank honored before. Let's see. The award-winning book is Harris's first novel, but her writing were honored before. No, if we were doing this type of thing, it would be was because it's a single novel, not were. Have been, but her writing have been honored before. Half of these you can just like look. That is specifically incorrect because it doesn't agree with the singular subject of one writing. Has been the award-winning her first novel, but her writing has been honored before. It sounds nice. Subject verb agreement. It does agree with this singular subject of writing. Let's just test the final one. R. The award-winning book is hers, but her writing are honored before. Does that even sound right? Like, we clearly can just see what sounds right. Half the time with these questions, what sounds right is right. C is correct. In order to prevent whatever, marine biologist has proposed that a saline lock system be installed here. The lock would increase the salinity of the lakes and created a natural barrier of water. Which one is correct? Uh, Increases in lakes and creates a natural barrier of water. It sounds nice. Let's keep that one in mind. Yeah, the lock would increase the salinity of the lakes and create a natural barrier. So right now, what I'm thinking is creates and create do sound nice. And creating a natural barrier, that does not work. The lock would increase the salinity of lakes and create a natural. No, we're talking about present. Created is just switching up the tense here. We're going into past tense here. So these two can be gone. Right now, let's break down why A is actually incorrect. A is going to be incorrect because the present tense verb of creates, it can't be used in the way would. Okay, hold up. The finite present tense verb creates can't be used in this way because the modal would to describe what the lock would do. Uh, this word would is showing like a hypothetical situation, and creates is more about it's happening right now. Like this is a true fact. Like it creates this as it's going. So it disagrees with would. Create is the correct one here because it's not actually happening yet. It's going along with the hypothetical of, yeah, the lock would increase the salinity and create a natural barrier of water. Yeah. This is since it's talking about the future, we're gonna have to go with create here. Okay. Paintings by this renowned 20th century US Were featured in Artist and exhibition at the Smithsonian. Okay, so we have a bit of a longer thing here. Let's see which one fits. Paintings by the renowned 20th century US artists, Thomas Hart Benton and Jackson Pollock were featured. Well, we don't really need that comma here if we're just going straight into it. And the semicolon for a list of two, uh, yeah, I don't really know about that. We don't need the punctuation. We don't need the comma there, so discard that one. Artist, artist Thomas Hart Benton and Jackson Pollock. Um, as we see here, the SAT likes to do this a lot when we're using a word like a general term like artists, and then we specify using a name or like two names here, for example. You don't need punctuation like this has here. This comma is actually incorrect, although it looks and sounds right. You don't actually need it. The SAT likes to do this. B is technically correct. We don't need a comma after because it's going straight into were featured and artist to artist, which is a continuation. This is all agreeing. B looks good. Let's just see why this is wrong. Artist Thomas, Hart Benton, and Jackson. We only have two people here. We don't have to separate it. Uh, this is incorrect because of this comma right here. And this is, as I said before, they like to throw the trick here with this comma on answer D. So we'll have to go with B, and that is correct. 22. In 1943, in the midst of this World War, mathematics professor was recruited to the U.S. military to help the war effort by solving complex equations. Hopper's career would involve more than just equations, though. As a pioneering computer programmer, Hopper would help usher in the digital age. Okay, let's see. For A, equations, comma, would involve more than just equations, yeah, we do need a comma after between that and the though, because that's going on as this little independent thing right here. This is a little break as an explanation. We do keep the comma. Would this work as a new sentence? Let's see. Would involve more than just equations. Though, no, that's because these play into each other. They'd have to be the same sentence. C is automatically out. And D doesn't even have a comma there. You need the comma in between because we're breaking off into this little clause here. So these two are gone. C and D can go. Why are we thinking A or B? What is going to be the differentiator? Well, B, it results in a comma splice. You can't use this comma to connect these clauses right here. So A is gonna have to be correct. Because yeah, we have the comma after equations. That's correct. The colon is to actually mark the boundary between the clause ending and the next clause. So it's ending this first half of the sentence more than just equations, comma, though it's starting a new reason here. So the colon is going to be correct, which is uh, answer choice A. 23, increased gender diversity is revitalizing the field of economics, according to this lady. The trailblazing accomplishments of Golden, winner of the 2023 prize, has attested, is attesting, attests to the value of scholars in diverse backgrounds. We have to read the rest of it. We already got to that point. Let's see which answer is correct. Of the prize for her work in the labor force, attests to the value. Okay. Has attested, is attesting, attest. The reason I like D, it sounds good here. Attest and attests both sound good, but the reason we would go with attest here uh, is because the subject verb, the plural verb attest agrees with the trailblazing accomplishments. Since you can use this attest plural, and we're talking about multiple accomplishments, this choice is going to be the best. For most of these questions, you really just have to go into what is the subject? Is it plural or singular? And which verb can you use with plural or singular? And a test you can go with the plural subject. For 24. During the English period, many writers imitated the epic poetry and satires of ancient Greece. They were not the first in England to adopt the literary modes of classical antiquity. However, some of the most prominent figures of the early Renaissance. Okay, let's see. They all have commas a little bit. This one has a semicolon. Can we use a semicolon here? They were not the first in England to adopt literary modes of antiquity. However, some of the more prominent, let's see, can we even go with a semicolon? Um, it's not technically correct because the information in the clause that is part of that's saying that the prominent Renaissance figures were also influenced by classical literature, it's contradicting the opponent, the information in the second part. So this is not adding on. It's not what a semicolon should be used for. That one's automatically out. Now we have to. Okay, we have three options with commas. They were not the first in England to adopt literary modes of classical antiquity. However, you do need the comma after however because this is a entirely new clause. This is not gonna work. Uh, these two, they have the separating after however, so these B and C are gonna be the possible candidates here. Uh, you can use however, comma, but technically, the comma there is not correct because it can't mark the boundary between two independent clauses. Another thing in the SAT, if you can write both of the sentences, like this first part of the sentence is a sentence by itself. And if you used however, some of these, whatever, these are two sentences right here. So if you want to use a comma, you need to have some type of you need to use like and, so, but, or. Otherwise, you can't use this comma by itself. So B is gonna be out. C is the correct answer just by process of elimination, antiquity. However, you can use the semicolon after because we are starting the new clause here, and this is just by itself, so we can use a semicolon to get C. Okay, there's a lot of questions. Yeah, okay, let's keep going. English poet and Shakespeare, contemporary John Donne, works much admired during his lifetime and the decades that followed, had at the time of their enthusiastic rediscovery by the early 20th century been essentially gathering dust for the intervening 250 years. Okay. And poets were works were much admired during his lifetime and in the decades that followed. This one, A, it is going to be incorrect because it's inconsistent with this supplemental, like, edition right here. The works were much admired, that's not gonna work. English poems, Shakespeare, contemporary John Donne's works were much admired in his lifetime, had at the time. That is also it doesn't fit because the verb when you're saying "were much admired," it it doesn't fit with that. Uh, you can just read it and see that it's not, like, nice. Works. English poet and Shakespeare contemporary John Donne's works, much admired during his lifetime and the decades followed, had at the time. Okay, so we see here works, comma, we're going off into this little tangent right here, and then another comma to close it back up, and we're into the rest of the sentence. That works best just because we're closing off this little clause here with this comma here. We don't need this were, had been. works is going to be independent by itself, and that's the choice that we're going to go with. Yeah, and that is correct. 26. We do this for 50 minutes. Uh, yeah, on the test, you're only gonna have like 35 minutes. I'm talking through all this a lot, but there's these little clues, like the thing with two sentences, you need to have the conjunction between the comma. If you can separate it into two sentences, like these little tricks, if once you can pick these up, you can do these questions in like 20 seconds. If you just know what to scan for, then it's really you don't even have to do half the stuff I'm doing.
Yeah,
But
that's one thing to know because like we're going really deep into it, but like next section we're gonna be able to like quickly like identify what's the correct answer just because we're going over it right now. So it's gonna be better for y'all when it comes to the test, so you're able to like recognize it and apply it while taking the SAT this Saturday.
right, right. Like when I was taking the SAT for, I wasn't doing, okay, I'm reading every single word here. What is the question asking? Let me read every single answer choice to go over it. Okay. The second I see a choice I don't like, it gets crossed out. I
Yeah,
see another one I don't like, it gets crossed out. If I see one that, okay, this is looking a little bit enticing, let me mark this down. And then I put it back in and like, okay, it works.
yeah,
You don't have to go into every single answer choice and, break it down for every single thing a part of it. But that's what I'm doing right now. For, next section, we'll just work through it as if we were actually taking the test. Okay, 26. Compared to that, the aluminum glass. Okay, silica glass as a significant disadvantage, as a dispersed, whatever, whatever. Silica glass atoms are so far apart that they are unable to reform bonds after being separated. Okay, compared to that of the aluminum glass, silica glass is at a significant disadvantage due to its more uh, dispersed atomic arrangement. Uh, this one, it's correct in its content. It's incorrect because for like the English conventions, because of the thing called a dangling modifier. Saying, the phrase silica glass first, and then immediately after the modifying phrase, immediately after this silica glass is at a significant disadvantage. Starting off with this again is a dangling modifier, and that's not allowed. So that's incorrect. B, silica glass has more dispersed atomic arrangement, resulting in a significant disadvantage. This is doing the exact same thing, basically. Dangling modifier, we're starting with silica glass again. Uh, it's same thing. The phrase silica glass right after our answer choice is suggesting that the glass itself is being compared to the aluminum glass, not its atomic arrangement. C, a significant disadvantage of this glass is that its atomic arrangement is more dispersed. Uh, it's it sounds correct, yeah, but again, dangling modifier. The placement of the phrase a significant disadvantage, right at the beginning is right after the modifying phrase suggests that the disadvantage is being compared to the glass, not the atomic arrangement of the glass. For D, silica glass atomic arrangement is more dispersed, okay, resulting in a significant disadvantage. Okay, so this is saying that the disadvantage to the atomic arrangement is that it's so far apart. This works because it's specifying what is that disadvantage. So that is going to work. D is correct for this answer for this question. Okay. Now we're going on to logical transition. So this is still like standard English. What is the like grammatically correct? But it's now different word choices. In November 1934, she was living in what must have seemed like the ideal city for a young artist. She was studying firsthand the color-saturated style of France's modernist masters and beginning to make a name for herself as a painter. She longed to return to her childhood home of India. Only there she believed truly her art could truly flourish. Well, we have a bit of a contradictory thing. She's saying that, yeah, France is beautiful. It's a great place to make a name for herself, but she wants to go home because that's where her art can truly flourish. So, still, that is it's introducing the contradictories. Like, while this is happening, France is super nice, still, she wants to go back to India. It sounds nice. Therefore, is implying that these are working hand in hand, that, because France is such a nice place, she has to go back to India. No, that's not correct. Indeed, she has to return. Well, these B and C are banking on, like, her leaving India is because France is so nice. It doesn't really make sense. These are two contradictory things. Furthermore, yeah, we're not really, writing historical essay, so still is gonna be correct because contradiction. 28. In 1974, Mexican chemist and US chemist discovered that chemicals called that were harmful to the ozone layer. Okay, their research was extremely influential in the fight against CFCs. It laid the foundation for a 1987 treaty that phased out the use. Okay, so we already have like a specificity here. Like it's showing how was their research so extremely influential. So regardless, that doesn't work. It's showing that it's influential and it laid the foundation. It's not in a contradiction. However, again, it's not a contradiction. Earlier, it laid out the foundation. No, this they did their research and then they got the treaty. So earlier doesn't work. B works specifically because this is a specification of how their research was influential. So that question, honestly, it shouldn't take you more than 10 seconds to just read this, realize what this is doing, and boom, we already know it's specific, so you can move on. 29. Another one of the transitions. With his room-sized installation, Norwegian artist succeeds in creating whimsical yet perplexing experience. When visitors set foot inside the fantastically blue room and encounter the life-size stuffed unicorn, they're both dazzled and confused, as if stepping into a strange and enchanting new world. Okay. First, we can use second. Uh, it's talking about the experience here, and then it's explaining what is going on in the experience. It's not like a secondary step to the experience. So A is going to be wrong. Instead, we're not contradicting it. We're not like going off on a new point. So instead is not correct. We're saying it's whimsical and perplexing. This is all whimsical and perfecting, details. So wrong. Indeed. Okay, I like that one because, yeah, we're talking about our experience here. Indeed, we're specifying what's going on in this room and what kind of world are we stepping into. Nevertheless, it ties again into instead. Nevertheless, is suggesting that we're going off on a different point, but we're not. We're specifying. So, indeed is going to be correct here. Okay, these are really easy. The ones where you go about like the notes, these ones you just scan. So I would read the question first for for this note type question. What are we looking for? And then we'll go back and read and see what type of information have we gathered and what's relevant. So he wants to emphasize the different distance covered by the Philadelphia and Lancaster Turnpike. Which choice most effectively? What's talking about the distance? 62-mile road. Wow, boom, distance right there. Is that correct? Yeah, it's 62 miles long. He talked about that, Philadelphia and Lancaster, and they're both connected. Do we even have to read the rest? Not really. It's a private turnpike. Nothing about the distance covered. Connected to Pennsylvania cities was built. This is the date. C is talking about the date. That's not incorrect. D is talking about It's just a historic Pennsylvania road. That's incorrect. A is obviously correct because we have the distance there. Okay, 31. This one's long, but let's see. Student wants to emphasize the aim of the research study. Which choice is talking about the aim of the research study? Most but not all of the oxygen comes from the sun. Okay. Some of the oxygen could be actually coming from the earth. Confirmed that the earth is sending, okay, there's our claim. Earth is sending oxygen to the moon. Uh, this is talking about their data collection method, the satellite collected data. It's not talking about the aim of the study. So aim, this one is gonna have to be correct. It's on a different point. B, before 2008, they wondered if the moon were receiving some of its oxygen. Um, they wondered if the moon were receiving some of it, but this is talking about the date. It's talking about before 2008. It's not having to do most effectively with the aim of the study. C, he set out to determine. He okay. At least says here he set out to determine. That's the aim. Like you already tell that's the aim. Whether some of the moon's oxygen was coming from the Earth. Uh, do we even talk about D? It's saying the final study. It's not saying the aim, it's saying the results of the study. C most specifically is telling what this guy set out to do and what he's researching. So C is going to be correct here. Oh my God, two more questions. More notes. Don't read all of them. What do you want to know? The aim of the study again. Okay, which choice most uh helps? Aim of the study, the factors that affect clutch size, the number of eggs have been studied in birds, but not so we're studying the eggs of lizard species. Larger size associated with higher latitudes. Um, okay. A is going over researchers wanted to know. Is that not like telling you the aim? That's like your keyword right there. They wanted to know which factors influence whatever, whatever, whatever. Uh, kind of a clear pick right here. B, after they learned that higher clutch size was higher latitudes. That's not like they didn't set out to discover the association with higher latitudes. They just set out to influence factors with clutch size. B is out. C, also just another, observation after the study. It's a result. It's not talking about what they actually set out to do. D, another thing, obtain clutch size and habitat data. It's talking about what they did, not what they wanted to do. A gives it away. Another one you can do in about 20 seconds. 33. Following notes. Wow, John Lennon, Paul McCartney. Wow, cool. Let's take a reference. He wants to make a generalization about the kind of study conducted by Glickman. Okay. Yeah, just about the study. What is the study here? Mary Glickman, Jason Brown, they used statistical methods to analyze the content. They concluded that 18.9% probability that McCartney wrote the verse for "In My Life," stating that it's consistent with Lennon's writing style. So they're saying McCartney didn't write it. Based on statistical analysis, they claimed that John Lennon wrote the verse of "In My Life." That's not correct because it's talking about the methodology using statistical analysis. It's not generalizing everything they did. So A is going to be wrong. B, there's only an 18.9% probability that he wrote. Okay, this is the specific result. It's not what are you talking? It's not a generalization. It's the specific result here. Uh, it's the data and the analysis of just that one song. So it's too specific for a generalization. C, it's likely that John Lennon, again, we're talking about the one song. It's not a generalization about the kind of study. It's just this one song. D, they use statistical methods to address questions of authorship. Okay, generalization. This is sounding really general. So it's explaining the kind of study, statistical methods, and it's what they did, authorship of this one song generalized. So D is gonna have to be correct here, and I am done. I'm gonna hand it off
Yep.
to my good buddy Anas. He's
Yep.
gonna be doing math module 1.
Yes. So now our agenda is gonna aim off to um. So we're just gonna aim it off to where we do the first module of each section, and then we do end up doing the second one for each section. So we're gonna go to math, and really math is definitely the easiest one to like learn. So I can say from experience where I can increase my score by like a great large number. So we're gonna go to our first question. So there's 27 questions, which is not as similar to the actual test because this one actually has a lot more questions compared to the actual test. I think it's probably like 5 more. So we're gonna start off right here. So question 1 states, a bus is traveling at a constant speed along a straight portion of a road. Okay. A lot of the time, word problems, you don't need to read off all of it. The equation d equals 30t. So you could really just go straight to Desmos, type that out. Alright, so we're going to actually do that. So d equals 30t. Now, it's going to give out a graph like this real quick. I'm just going to show it. So this is like a function. So this is similar to an actual linear function where like it's increasing by each. So the rate of change is 30. So each like unit increase of x on the x-axis by 1, our output is going to end up as multiple of 30. So when we're looking at this, we say equation d equals 30t gives a distance d. So we're looking at a distance formula, and we're asked how many feet from the marker will the bus be 2 seconds after passing the marker. So 2 seconds in, we're going to substitute 2 for t. 30 times 2 is 60, that's C. We already got our first answer. Second question. For a particular machine that produces beats, 29 out of every 100 beats. So this question represents you have a large sample, and out of that sample we take something out. So we're going to have basically kind of imagine like a piece of pie, and we split it into quarters, and we take one of those slices, then we take in 1/4 of the entire pie. So in this, we have 29, so 29, beads out of a whole batch of 100. So we're told that 29 of them are defective, or had the probability of being defective. And from that batch, if they have like 29 of 100 of them being defective, if we randomly select them, that means out of all that batch, we could end up with 71 out of 100. So 71 of the beads are not defective, and we could select those ones, or we could end up selecting the 29 out of the 100 beads. So we could select one or the other, and it asks for the probability of selecting a bead that has a defect. So C will be the answer. We have 29, which is the defective number, and then we have 100, which is the total number. So you're going to have the condition over the total. Question 3, all you got to look. So what is the y-intercept of the graph shown? You just got to look at the y-intercept. Right here it's 8D08. 4, which expression is equivalent to this? What you really want to do is, the idea is you want to distribute the whatever sign that you're given. So, right, it's a plus sign. If it was a minus sign, we would distribute a -1, and then this will make everything here negative, and if it's already negative, then it will make it a positive. So right here is a positive, so we're just going to be adding. So 2x squared plus x squared, that's 3x squared, so we can cross a and b. X plus 6x, that's 7x, so these two are still remaining. Now we have -9 plus 1, so it's going to be -8. Because when you're adding, so like basically it's just going to become a negative, and you don't add, or like it won't be like a negative minus a negative, because we still have a positive, and we have a positive right here. So D is the answer. 5. An analyst collected data on the price of a carton of grape tomatoes at 30 locations selected at random. So, of course, unessential information. The mean price of a carton of grape tomatoes in Utah was estimated to be $4.23 with an associated margin of 0.08. So, which of the following is a plausible statement? So, when we ask about a statement, we basically want to like interpret it what we're like given. So, the mean is 4.23, and then we're able to go $8 or 8 cents from this. So we can say any plausible value is going to be between this minus 8 cents and this plus 8 cents. So in this, we can say, okay, so right here it says it is between 4.15 and 4.31. So that's how we said it has to be in that interval. Like, so I said plus or minus, so we do minus. It must be greater than this minus 8 cents, or it must be less than 4.23 minus 8 cents. So we're going to go over the next stuff. So be less than, so that's basically the opposite I just said. It has to be greater than this and less than this. It is less than 4.15. Well, we don't have our upper bound. Or actually, we do have an upper bound, but it's a wrong bound. So that's wrong. And a D is greater than 4.31. That is wrong as well because that is the wrong bound as well. So what value of x is the solution to the given equation? So when we're given this, really all you have to do is just take this 2.6. So we want to have it to where we isolate x. So the way we can do that is just subtract 2.6 to the other side, and we're just left with x equals 0.2. So that would be the answer. And now number 7, out of 300 seeds that were planted, 80% of them sprouted. How many of these seeds sprouted? So you can use a calculator for this. All you gotta do is just do 300 times 80 over 100, which 80 over 100 is 0.8. So out of 300 times 0.8, the answer is 240. So 240 of the seeds actually sprouted. And if it were to say which seeds did not sprout, you would just say 300 times 1 minus 80 over 100, and it's going to give you the opposite of the opposite of the condition. And then if it were to say which ones didn't sprouted, we would say 60. For the linear function, f b is a constant and f of 7 equals 28, what is the value of b? So we could say, if we were to just have f of 7 equals 28, we could say right here, let me annotate it like this. So we could say from here, we could substitute 7 right there, and if we could substitute 28, so we can substitute 28 like that, and then we could say 4, 7 plus b, and then 4 times 7 is 28 in itself, and if you subtract it to the other side to isolate b, you're just going to be given b equals 0, so A will be correct for this. And I don't think it's going to go away. It's whatever. Okay. Now, question number 9. Right triangles LMN and PQR are similar. So we're given respective angles. So L and M correspond with P and Q. So these first two and these first two correlate with each other, are connected with each other. Angle M. So we're looking at angle M now. Angle M has a measure of 53 degrees. So we can look at here. So L and M correspond to P and Q respectively. So M and Q are similar. So we're asked what is the measure of angle Q. We're told that M is 53. So since it corresponds with Q, we can say that Q is also 53. So it's B. Number 10. What is the equation of a line that passes through the point 0, 5 and is parallel to the graph of y equals 7x plus 4 in the xy plane? So right now we're given an x value of 0, so that means out of the x-axis we're actually intersecting with the y-axis. So basically all we're really doing is touching the y-axis, And there is a case where we touch the x and y axis, which is when we're at 0, 0, which is the origin. But in this case, we're just 5 units above the x-axis. So that will be considered our y-intercept. And it's kind of similar to a little earlier right here. This was our y-intercept, and when we're solving for it. So we can see and it's parallel to the graph. So with a parallel slope, it basically means that this slope and then the slope that or the equation that we're looking for is gonna have the same exact slope. So we can cross off A because that's not gonna have the same slope as this, and we can cross out D because that doesn't have the same slope. We need a 7x slope. So now we're between these two. Now we're given that this, well, basically it passes through the point 0.5, and that will be known as our y-intercept because when x is 0, that is our y-intercept. When y is 0, so this is 0, and then let's say this is 3, then that will be our x-intercept. Basically, it's just kind of like an inverse kind of thing to consider. You can always plot on Desmos, and you'll be given, so since this is the y-intercept, we can correlate with the y equals mx plus b formula, and this will be our b value, so for that 10 is b. Question 11. So which is the following equation appropriate? Okay, so we're given this, and we just have to like kind of connect it. So we see that with this like plotted line, we could assume it's like, okay, it has a negative behavior. So for each increase in x, we see an actual decrease in y. So the output's decreasing for each increase. So with that, we would need a negative slope, which would mean that we would have a minus sign with the coefficient in front of the x. So C and D are wrong, and the thing is that we're also remaining in the quadrant 1, and we have a positive y-intercept. So because of that, A is wrong, B is right. So question 12. A model predicts that the population of Bergen was 15,000 in 2005. It also predicts that each year for the next 5 years, the population increased by 4% of the previous year. So this is a compound equation. So basically, we're stating that we have an increase. So we cannot have anything less than the previous year. We have to have something greater. So we're given an equation. So it will be A, and then in the parentheses, it will be 1 plus or minus, depending on what we're given. So plus or minus the percent over 100, and then the exponent. So we can tell A is wrong, B is wrong, because this coefficient right here has to be a constant, or else, for example, this will be astronomically large, and we're not actually even going near a value that we're actually expecting. Because at, like, let's say, for example, at let's say year 0, we're gonna have this as 1, and that's gonna be 0.96. That's not gonna be correct because our first year we have 15,000. So we're gonna have to represent that. So A and B are incorrect. So this is going to be our base value, and then I did 1 plus or minus. It will be addition if it's increasing, subtraction if it's decreasing. So we see it's increased from the previous year, so it will be 1 plus 0.04. So it's going to be 1.04. The answer is D. Question 13. The solution of to the given system of equations is A, B. What is the value of B? So you can do this on Desmos, but I would prefer to do it on hand so you'll be able to understand it and be able to apply it. So one way we can do is elimination. So we can actually like eliminate from this equation this equation. So we can say, okay, these two cancel out. So we have 8 minus 4, because it's like we're basically distributing a negative, and we're gonna have 4b, and that's gonna equal 100. And already, because 198 minus 98 is gonna be 100. B, all you gotta do is just divide 4 onto 100, and b is just going to equal 25. That's all it asks for, so we have our answer. And then you can just do that on Desmos. You just like plot, and then you'll find the intersection. So you can just plot these like two values, and unfortunately Desmos does not understand this. They only understand x and y as implicit values. So that's just the only things that it can like kind of take in, unless you set a value for a and b. But you can just substitute for a and b. So we're given that respectively this is x and this is y. So we can just say that's x and that's y. So 2x plus 8y equals 198, and then that stuff. And then you'll just have that. I could probably quickly show it to you. So it's 2x plus 8y equals 198, and then 2x plus 4y equals 98. And then you can zoom out, and then section intersection. I think I typed that wrong. It's fine. Alright, I already got you all the answer, so we're gonna go to the next question. The expression 90y to the 5th power minus 54y to the 4th is equivalent to this equation. What is the value of that? So now this is a case where you could actually use linear regression. So we're just gonna quickly look at it. So we have 90y to the 5th minus 54y to the 4th. Now, when we're looking at linear regression, basically we kind of take in this as for all values of y. So right now this would not work because we were taking this as like if it were to be all values of y. So the way we can do that is we can add, so you can just type down, so just type a number. You could do 1, 2, 3, whatever. They just have to be consistent. So we have y1, y1, y1. And the reason why is because this makes it more of a, as a constant rather than just a like stature. And since this is like a straight equation, so it's equivalent, and it's not like going to be equivalent to, for this case, it's not going to be equivalent to all forms of r or y. We're given that it's asking for the value of r, and r is a constant, and we're gonna take as y as a constant because I'm just gonna like type something out to see if it'll remain the same. So we can take y as a constant, or we can keep it as this. So this random function basically creates as, okay, so we have a constant, but we don't want it to be constant. We want it to have multiple values for itself. So we substitute multiple values, and Desmos is able to kind of create with those values an estimation for the rest of the constant. So we have r equals 6, and that is the answer for this question. So now we're going to go to question 15. The graph of y f of x is shown, or is defined by that. They're constant. For how many values of x does f of x equal 0? So you can just look at here. 1, 2, 3. The answer is C. Just look at the graph, right? It just provides it for you. So, 16. The area, square centimeter. Okay, so we have an area in square centimeters of rectangular cutting board, which is represented by this. So we have W, which is the width, and then the length. So I'm just gonna assume that since it's in square centimeters, we already took the area of it, so right here, and W is already the width, and we're gonna assume that W plus 9 is actually gonna be the length of it. So we can actually say that W plus 9 is the greater version of W. So we can say D is the right answer because we already have W, so this would not work out because this is just basically the area again, so that's wrong. And we're already given that W is the width, so B is wrong itself again. And 9 is just, well, that's just 9. That's just the difference between the width and the, like, that's just how much you have to add for the width to get the length, so that's wrong. The given equation relates to the distinct positive numbers of that, and which represents that in terms of P and K. So, no fret, this might look a little scary. All you have to do, multiply this, so this function right here, multiply to the other side. So now we're given 4j plus 9, because that's what we're trying to like kind of get out of. And then we're going to have P equals K. And now what we can do to isolate this, because we need to distribute P, because this is a function itself, or this is like equation itself that must remain at its like current state. So, but we're asked about this one, so the way to find it out is that we can just divide P to the other side, and we're just gonna have this is gonna equal K over P, and that's A. 18. Circle A has a radius 3n and circle B has 129n. So the area is how many times? So we have pi r squared. So when we're considering a circle, the area is pi r squared, and we have a radius of 3n, and we have a radius of 129n. So we can square that. So 3n is 9n. And then I might need a calculator for 129 squared. So 129 squared is 16,641. So 16,641. And it is asking for how many times. So we can do 16,641 divided by 9. And we are given 1849. So it asks for how many times. If it asks for how much more circle B is, then it will just be subtraction. So, but in this case, it's just multiplication. So, how many times? What can you multiply with A to get this number? So it's D. So 19, the measure of angle R is 2 pi over 3 radians. The measure of angle T is this many radians greater than the measure of angle R. What is the measure of angle T in degrees? So we can convert this. So we can make it to where it's the same denominator. So 12 divided by 3 is 4, so we need to multiply this by a factor of 4. So we'll be given 8 pi over 12 and 5 pi over 12. And then since it's greater than, we would just have to add these two, and it's just 13 pi over 12. And the way we can so the way that we convert radians to degrees, we basically take, it's kind of like stoichiometry. So if you ever taken chemistry, it's kind of like weird. So basically the way we do it, so like let's say we have x over x, that equals 1. So we can make it to where we can multiply something by this. So we can cancel out the pi, or we can multiply to where it equals 1. So we're going to have a pi right here, and then we want to convert it to degrees. So for each radian, we're traveling in 180 degrees. So we're going to have 13 pi, so these two cancel. So now we're just given 13. So we have 180 over pi, and we're just going to multiply by 12. Or 13 pi over 12, I'm pretty sure. Yeah, so 13 pi over 12, and we get 195, and that is the answer, C. So now we're on question 20. Y equals x squared minus 14x plus 22. The given equation relates to variables x and y. For what value does it reach its minimum? So it straight just asks what value of x. You can just type this out into Desmos. I'm going to do that. I don't really want to waste no time, so we're just going to do that. So we're going to have x squared minus 14x plus 22. So we can see from here the minimum y value is negative 27, and we reached that with x value of 7. So the answer is 7. 21. A small business owner budgets $2,200 to purchase candles. The owner must purchase a minimum of 200 candles to maintain the discounted pricing, as the owner pays 4.9, so this much per candle with small candles and 1160 per candle to purchase large candles. What is the maximum number of large candles? So we can represent that we had to have a minimum of 200 candles. So we need 200 candles, and we can say, alright, so we're gonna have small plus large. So these two must add up to 200. And with that,
Anas, can
yeah.
you switch your screen?
Oh yeah, my bad.
You're good.
Yeah. Alright, I'm gonna read it once again. So, small business owner budgets $2,200 to purchase candles. The owner must purchase a minimum of 200 candles to maintain the discounted price. If they pay $4.90 for small and $11.60 for large, what is the maximum number of candles the owner can purchase to stay within the budget? So, we're given that we need to purchase 200 candles. So, we have this function right here. And then we have a budget, so we can't go over it. So, 2,200. And then we have to fall under it, or less than or equal, or greater than or equal to. So we're gonna have 4.9 s plus 11.6 l, and now we can type that out and figure out what we can do with it. So I'm just gonna quickly type that into Desmos, and then I'm gonna share that part. So we can create this thing called a list, and it's gonna help with this process. So 4.9 s plus 11.6 l, and right now we are seeing, so s could be 17.9 and l can be 182. And we don't want, like, we can't, of course, buy like half a candle or a portion of a candle, so we gotta like round down for this one and round up for this one. So we can say that the maximum number of candles for large candles, we can actually buy 182 candles from that. So I'm gonna explain this real quick. So basically, Desmos, you can type this into a list, and this tilde or squiggly line approximates using the given information. And with this given information, so we're separating with commas for their respective equations. So 200 is going to be with s plus l, and 2200 is going to be with 4.9 s plus 11.6. And it does all that work for you. It will just approximate for you, and you're done with that. And sometimes you might have some struggles. A lot of times it's trial and error. I believe you can learn it. There's just a little brief down on it. So, other than that, we're going to go to the next question. So, which point is a solution to the given inequalities? So, we can also type this into Desmos. So, we're given that y is less than or equal to x plus 7. And then y is greater than or equal to negative 2x plus 1. Minus 1, actually. Okay. Minus 1. And we're going to show this. And we're going to look at this. So it's going to be like, you know, a pop-up window. So you can just like compare. So the first answer is negative 14, 0. That's not even out. So we're kind of looking for this shaded area where a point is in. So that's not even in there. So we're going to go to the next answer. So negative 0, negative 14. It is in one shaded region, but it's not with both, so it's not an intersection. So that's not right. How about this one? It's still not. It's still in one of them, but not both of them. So now our last answer, which is D, and it's well coincides with both sections, shaded regions. So that's going to be the answer. So the answer is D. Okay, frequency table. So summarizes a data set of weights. Rounded to the nearest pound of 71 tortoises, a weight of 39 pounds is added. So we added 39 pounds. So these are the weights, and we see that an extremely large number compared to these weights is added to the data set. And creating a new data set of the weights rounded to the nearest pound of 72 tortoises. Which statement best compares the mean and the median? So if you take in statistics, you'll understand the kind of the connection with median and mean with outliers, because this is how we call an outlier, where it's extreme value compared to the normal data set. So the mean is very sensitive to any outlier, so it will be pulled towards the outlier. So since this is greater than the average set, we're going to see that the mean is a lot larger, but the median is very resistant, so it's going to remain in the same area. So mean of the new data set is greater than the mean of the original, and the median, well, I said that the median is going to remain very similar or very basically the same, so that's wrong. Median is greater and medians are equal. That could be an answer, so I'm just going to circle that. Median less than, that's not the case, because that only case it would be less than is if the outlier is a lot less than. So let's say if it's a 1 pound tortoise, so that's not wrong, that's not right. Mean is less than, like I said, it's not, so you can cross that off. Okay, so which of the following are solutions to the given equation where a is a constant and a is greater than 30? So what we can do is that we can have this and we can subtract it to the other side. So now we can have this equation. So we can have 0 equals x minus a, and then x minus 29, and then don't even have enough for it. We're just gonna come down here and then minus x minus 29 again. So with this, we have we can see a common factor. So here and here, we can actually take that out. So we can just say x minus 29, and it's gonna look a little funky. So we're gonna have x plus a. So we're just gonna have a little square bracket, x minus a minus 1, because we took that out. We took this out, and then that's just gonna remain 1. That's the same thing with here. Since we took this out, that's just gonna be equal to 1. It's just kind of like taking the greatest common factor of something. So let's say we have 39 and then minus 13. We could take the greatest common factor as 13, and that's gonna equal 3 minus 1. So that's the same thing right there. So we take the greatest common factor, and we could say, so since this is there multiplication or anything, we can see this as x minus a minus 1, and so we can use zero product property with this. So we have two multiplications. So we have this right here, and then this right here. I don't know if I can. Okay, I can circle it. So with this, we have to find where x equals 0. So we can use zero product property. So we set equal to 0. So we could say this equals to 0. X could equal 29. So this right here is correct, one of our solutions could be 29. And then with this one, we need x, so we can add a and add 1 to the other side when the other side's 0. It can also equal a plus 1. That's another solution. So we never found 1, so the answer is C. So 2 and 3 only. In the xy plane, so question 25 asks, in the xy plane, the graph of the function this intersects the line yc at exactly 1 point. What is the value of C? So C could be anything, but we're going to think about this. So if it only intersects, and here, so we have this. Now the only problem with this is that there's only one exact point, which is the vertex, where we could possibly have a tangent and only intersect it once. Any other line is always going to fail that and is always going to intersect 2 points. So we're going to be looking through the vertex formula. So it's negative 2b over a. So 9 right here, so negative 2b over a, so 18, negative 2b over, hold on. No, you know what, I'm just going to show you on Desmos, like, it's a lot easier. So we have negative x squared, so you can see how it opens down, just like how I kind of like showed with the curve, plus 9x minus 100, and it's down. So right now we're sitting at this value right here. So this is the only point where we can find an intersection. So we need to find a value of y where we can intersect that. Well, honestly, I don't feel like doing all that, so we can just type negative 79.75, and then we can just type click this fraction button so you can find the most simplest form of a fraction, and you can see it's 319 over 4, and that gives us C. So that's for that, and we're gonna go to 26. So the function f and g are defined by the given equations where x is greater than or equal to 0. Which of the following equations displays as a constant or coefficient the maximum value of the function it defines where x is greater than or equal to 0? So we're given these two equations, and we have to see from these. So when we're given like seeing a maximum part of this, it's really badly written, I can't lie. Which of the following equation displays as a constant or a coefficient? So we're going to be seeing one point or one time where the constant that we're given here is kind of present in one of the, like one time. So so we're going to look at this. So we're going to look at the base real quick. So we have a 1.25, and then it's taken to the x power. So it's larger than 1. So like I said, if it's larger than 1, you're going to see an increase like this. But if it's less than 1, it's going to be like this. So it's kind of like the question that talks about compound increase. So where a value is like compounding. So if it's less than, so let's say population, if it's less than 1, then it's going to be decreasing like this. So we're going to have a declining population. But if it's increasing, then we're going to have an increasing population, as shown as with the graph. And since it's increasing, we are not going to really see a maximum value. The reason why is because it's infinite. It goes on forever and ever and ever. Alright? You can see if it peaks off there, but there's no bounds, so we're going to see that it continues increasing. However, with 2, we have decreasing. So it says 0.73. Kind of blocked it off. So 0.73 to the x power. And we're going to see this. Now, like I said a little earlier, anything that's taken to 0 is going to equal 1. So we're going to see that the greatest value is going to be 9 for that. And we can see that that's the coefficient right here. So that's the only thing that's going to be true, and B is the answer. And 27. Alright. So last question before we're going to ask if y'all want to continue. So the perimeter of an equilateral triangle is 852 centimeters. So adding up all the sides, 852. The 3 vertices of the triangle lie on a circle. So you have a circle, you have a triangle. The radius of the circle is this. What is the value of W? So we can say that since we have all the side lengths, we can say that one of these, this is kind of like a chord, is 852 divided by 3. So this equals to, simple terms, it's just 284. And we can form a new little triangle. So we can bisect it. So when we're given something like this, we can actually like take it in half. So right here, we just like cut it in half, and then we form right triangles ourselves. So then right here, this will be perfectly bisected. So we're gonna be given half of this length already. So 284. So right here, we're gonna be given 142, and this is still gonna remain as 284, and that's gonna be our hypotenuse and stuff. And we are given with 30, 60, 90. So a 30, 60, 90, so this could be 30, this could be 60, and this is 90. So 30, 60, 90 represents a rule with triangles. So this would be 142, and then you see the radius right here is this. Well, with so with a 30, 60, 90, how it works is you will see the shortest length. So we have x. You can see the second longest length, which is this, and then we can see 284. So from alright, and then we have 284 as our large hypotenuse, so it's like double. So you'll see a double right here. And damn. Yeah, so we have a sign like should have labeled this actually. Alright, we're just gonna label it real quick. A and O. So right here we see with W and square root of third. Square root of 3. So okay, we're gonna take a little drawing break. Alright, so we're gonna have this again. And we perfectly bisected it. We're gonna have that. We have the hypotenuse, so that's like the length, and then we have 142, and then we have a 30, 60, 90, and we have length where this will be half of this, and the side AM is So we had AM right here. So this is just this times square root of 3, and we can be given that this length. We're gonna come through here. So with MO, we can have this. So it's gonna be based off how we said that the radius is that, and AO right here, it's able to be perfectly like aligned with the center, and when we're aligned with the center, that will be given as our diameter, and your radius is going to be your diameter divided by 2, and so we have 284 and 1, and then so we have 284 and we have 142, and then AM, so we're gonna have this multiplied with square root of 3 again. So we're given that this is connected with MO. So right now this equals 142, and we're going to multiply with square root of 3 again. So now we're going to be given is 3W over 2. So then we're going to have the same thing. 3W equals 142. We're going to multiply that. So it's going to be 284 again. And you're going to divide that by 3. And then that's going to be our final answer. So 284 divided by 3 is our W value that we've been looking for. So that's the end of module 1, and I'm just going to ask you right here, if y'all want to continue, state it. If y'all don't, also state that. Oh.
Okay.
Just less.
Do you have anything left?
Nah, I think that was it.
Alright.
Alright, well.
I already had ideas for module 2, but like it's already 9 o'clock, so
Yeah, I was like,
yeah, I
honestly
guess we
trying
could
to
just be
write
done.
things, you know.
Alright. So dude, we just did 2 hours of just presentations. Yeah, that's freaking service hours in the bag.
That's straight. And then like we can